scientific innovative research, IIT its main research interests are the areas near scientific materials, concrete technology, solid waste utilization, synthesis respiration, geopolymer concrete, distress diagnosis, and rehabilitation of structures. He is deeply associated with more than 1,900 including scientific research and consultancy projects. Contributing
Shalini,
scientific research in
Shalini, it's not
international
clear,
and
ma.
national.
Mute others.
Ma'am.
Mute others. It is not clear.
Okay, ma'am. Ma'am, 1 second.
Privileged to welcome Dr.S.K. who is presently Senior Principal Scientist and Head Cement and Concrete Composite Division at CSIR Central Building Research Institute, Roorkee. He is Professor in Academy of Scientific Innovative Research, ACSIR. His main research interests are in the areas of newer cementitious material, concrete technology, solid waste utilization, carbon sequestration, geopolymer concrete, distress diagnosis, and rehabilitation of structures. He is deeply associated with more than 1,118 sponsored research and consultancy projects and published more than 105 research papers in SCI journals, international and national conferences. He has also published 2 books, edited 3 proceedings, and 4 training manuals. He has supervised several MTech and PhD dissertations. Singh is a recipient of the prestigious Eminent Engineer Award of IEI in the year 2016, Young Scientist Award of Council of Science and Technology, Government of UP, India 2000. Professor Singh is active member of BIS, IRC, and other committees. He is fellow of Indian Corporate Institute and Institute of Engineers India and member IRC, ISWE, ISC, MS, ACI, ISET, and IGS. He has served as Vice President, Indian Concrete Institute during 2011 to 2013 and Honorary Secretary of the Institution of Engineers, Roorkee Center for the year 2008 to 2010. He has also served as founding coordinator and honorary secretary of the Ghaziabad chapter of Indian Concrete Institute from 1997 to 2000. He also served as member of National Executive Committee of ISEE, ISCM, and other professional bodies. He has organized several national and international workshops, seminars, and training programs all over the country and delivered keynote lectures in many national and international conferences. He has widely traveled to several countries such as USA, England, Australia, Greece, South Korea, Sri Lanka, etc. A warm welcome to you, sir.
Sir, over to you, sir. Thank you, sir.
I'm audible. Hello. Hello.
Yes, sir. Yes, sir.
Yeah, okay.
Yes, sir, you are audible, sir.
So thank you very much. I'm really honored to be part of this 1 week this faculty development program organized by Sona College of Technology, Salem, and really it's very nice and good to be associated. Really, I am being continuously in touch with the Professor Salin Prabhu, and we interacted at several occasions, and we are very much interested to have some collaborative activities, and I will look forward to have. So as you know that I was yeah, my slide is visible.
Sir, your slide is visible, but not the content, sir.
Yeah, it is okay. It's okay.
No, sir.
It's not invisible. Okay, let's I can again check it.
It's not visible.
Okay, no problem. Yeah. So yeah, is sharing again. It is visible right now in a slide.
Yes, sir. Now it's visible, sir.
Yeah. So thank you very much. Today I'm going to start talking about recent advances in building materials. Initially, I was thought I will going to deliver on latest technology and system materials for prefab system, but right now I have changed, and rather than I have been focused more on new cementitious or waste utilization, which is a requirement of the country. So somewhat I have changed only today morning, and so I'm been concentrating on that. If you look into the challenges before construction sector, so you know that we have a very problem to getting good quality natural resources, and also we have to conserve, so we have to go for alternative materials, and also that energy conservation. So we have to do whatever the materials process technology, if it is a production of cement or its production of fine aggregate, coarse aggregates, or all those things, we have to go for a energy efficient system. And utmost important is that reduction in greenhouse gas emissions. So as you people are aware that right now everybody is looking to have a system so that we can have a safety to our environment and those things. Recently, that climate changes has submitted their report. If we are not able to reduce our greenhouse gas emissions, so that we have a leverage of 1.4 degree centigrade on global warming, so that can be reached as early as maybe by 2024. So that all over the world people are being pressing hard to have how we can have reductions into the greenhouse gases. Recently, you know that some fourth week of September, and there was RE100 initiative held at a Climate Week in New York, NYC 2021, where you know that industry, that business holder, where Ultratech Cement has become a part of that RE100 initiative, that is a renewable energy 100 initiative, means they have agreed to change their system to be 100% renewable energy utilization by end of year 2050. So really it's good news for Indian and other cement manufacturing units as the same way. You know, Dalmia and others, they are working towards how they can minimize the energy requirement, and that should be a focus on renewable energy. So that those can be reduced. And I was looking their data, Ultratech. They have been right now they are being using by mixing the renewable energy with the existing thermal energy and other things by 13%, and they have targeted to by 34% by year 2024. So it is a big big changes. Major energy is being consumed into the construction sector, and if you look into that energy and greenhouse gases, so our this is 35% our energy consumptions is on our residential building, non-residential building construction industry. So it's not much on building, but operational of the residential building demands as very high, and we have to look for other renewable energy, or and people are working on different aspects. So getting a net zero building, they are using thermal power, wind power, and other things to make those, and making their retrofitting, green retrofitting, all those things to negotiate or reduce those energy demand into the inbuilt or that our built houses and other things. Similarly, if you look into that emissions, so that participated about 38%, and building construction itself about 8 to 10%. So it's a very high. So we have to reduce on those areas. So every organizations and government, Niti Aayog, climate changes, everybody is behind that, how we can reduce those greenhouse gas emission as well as global energy demand. So that was there. So these can be achieved if you look into the sustainability aspects, that as we are aware that three major important pillar is sustainability is environment, economic, and the social. So we can, if you look into all three things, and we can manage all three pillars in an effective manner, so we can achieve our sustainability goal. And so what is that sustainability goals identified by climate change, IPCC, 17 goals. And if you look into that, our infrastructure and sustainability development goals, sustainable development goals is being contributing in all 70s. If you look into that from goal 1 to 7, we are enhancing access to basic services, and from 11 to 15, really where our work should impart, that is promote environmental sustainability, and 8 to 10 and 16 70, that is supports to our inclusive growth. So but if you look into that very particular towards building constructions or those things, so we are being meeting the requirement, that is good health and well-being, that is SDG goal number 3, affordable and clean energy, that is goal number 7, and decent work and economic growth 8, industry and innovations and infrastructure, that is 9, sustainable cities and communities, that is 11, and responsible consumption and productions, that is 12, climate action 13, life of land, and that is important for that our growth. So all all our goals are being here. To achieve all those things, if you look way back, some years back, we are taking materials, you know, that I worked on different part. I have worked as a project director in National Highways Authority way back in 2000 to 2005. So what we do, we identified a source, and then some, you know, hillock, we blasted that and start getting good quality aggregates and putting our plant. So we are taking it, making our materials, using it, and throwing. So that was being known as a linear approach. And till some, if you know, 10-15 years back, everybody is doing like this. So if you are making a house, so whatever materials is being, we are not able to use, that is thrown away. So that was a big problem in a both manner, because that was the depletion of our natural resources, which is we are not right now. If you look into that, we are not getting good quality sand, and everybody is looking, you know, manufactured sand or alternative type of materials or good quality coarse aggregate also. So because we are our approach was towards the linear side. So nowadays the things are changing, and we are looking towards the circular approach, where we are taking a raw material, we are processing, we are manufacturing, we are utilizing those, and whenever it is required, we are, and after its life ended, we are recycling that one, and we are recycling after that, and again if we are utilizing into that raw material. So and whatever the residual materials, that is we are minimizing, again we are looking where we can utilize those material again. So to achieve a sustainability, we have to have building a circular economy. So without sustainability, we could not achieve our goals of our IPCC, and similarly it can be achieved only by building a circular economy process. So that is the utmost important things. And I have tried to make it to those things how if there is some material, if it is it's not good raw material or industrial waste, so that also can by carbonations or what we say carbon sequestrations, we can enhance its properties mechanical as well as utilized. So it can have a steel slag or biogas or lime sludge, red mud, bottom ash, and we can utilize those material as a building materials, newer building materials, and can be uh, can sustain our that sustainability aspect. So that is the important thing. So same thing, that we have design, produce, distribute, and uses, recycle, and recover. Whatever the waste will be there, that will be going to be thrown away, or we process further to make it, or we can utilize those as carbon sequestration. So this is, and I'm coming to my next slide, that is sustainable constructions. So always people ask, what is the sustainable construction? So it is the reduce resource consumptions, reuse of resources, protection of nature, natural resources and material. That is the utmost important, that is the recycling and reuse of construction and demolition waste, enhancement of service life of structures, reduce environmental impacts of cement productions, greater use of supplementary cementitious material, research and use of emerging materials and technology, greater use of renewable energy, effective control and construction management system, eliminations of toxic material, applying life cycle cost analysis, and last but not the least, focusing on quality. That if you look into that buildings or our infrastructures, if you have not focused on quality control during its constructions or during its initial stage of materials, so a lot of problem occurs and it could not sustain up to its life. So again, that lesser life, we are using again newer materials, so that will be a big thing. So our main aim is to use of emerging materials and technology into the constructions. So what I was being initially, I was thinking I will focus on latest materials and technology in building constructions, that is particularly in prefab technology. But if I have changed, towards on waste utilization, so you can focus on that emerging materials and technology. Today, Honorable Prime Minister is inaugurating some lighthouses project by Ministry of Housing and Urban Affairs in Lucknow. So they have used the new technology based materials are using, that is in Indore they are constructing you can in place or sandwich EPS panel based housing, and also that is a light gauge steel structure in some part, some 6-7 technology, and that about 1,000 houses has been constructed with those newer material and newer technology in country, and that has been most probably has been at 11 a.m. That has been to the people, so who is going to use those materials. So that type of things we have to work. And if you are going on prefab and precast technology, so not only you are using newer materials or new technology, also you are saving a lot of materials which is being waste on cost in situ construction. So those are the important. But today I am been concentrating on another subject. So that was been. So I have been defined, and what are the sustainable materials? Again, this is the composed of renewable rather than non-renewable resources that should have environmental responsibility. Means should have a minimum energy requirement during its process, or minimum possible environmental cost sustainable, low energy utilizations in manufacturing as well as its functioning, easily recyclable, efficient, durable, and longevity. That was the things. So that as we are aware that if you look into the ordinary Portland cement that is being produced, and it is one of the oldest. We are using about 2 centuries, more than 200 years. Cement is being used, and we are that accustomed with that material, utilizing those materials. So 200 years we are using, and nobody else can think other material other than the cement. But definitely there is a several other type of cementitious material are available, and we are aware that about 1 ton of ordinary Portland cement clinker produces about our cement produces about 0.66 to 0.85 ton of carbon dioxide into the into the atmosphere. And this carbon dioxide is a major issue, and it is being from calcination of calcium carbonate or lime. So this is the process. So people have started thinking how we can reduce this one, because major CO2 emissions is being from the calcining part of limestone. So this is not only from climate change committee, or that our Niti Ayog or other, and several rather than cement manufacturing organizations, they are under tremendous pressure to reduce their CO2 emissions and also energy consumptions during its fabrications or production. So they are. So it started with that some 10-15 years back. Code has also been continuously modified to utilize supplementary cementitious material, so that, and that clinker to cement reductions into the clinker to cement ratio. So that initially, if you look into the in a cement manufacturing, clinker is about 95 to 96%, and 4% of gypsum. If you look into the ordinary, then code has allowed you to use performance enhancer by 5%, and further 5% as a admixtures different types. So they can use like pozzolanic materials about 10% in OPC, as well as per our revised IS 269, that is 2015. So that and that basic aim is to reduce our anthropogenic effect of CO2 emissions. So continuously people are working, and different type of other type of cementitious binder based on adding to the pozzolanic material, that is called Portland pozzolana cement, composite cement, slag cement. That has been evolved, and it has been started using, where that clinker to cement ratio are getting reduced. So that was our aim, and this one. So that people had started some 10-15 years back to use supplementary cementitious material into the cement, and they are reducing the clinker factor into the binder. But people could not think beyond that. Then some started all over the world, people had started working how we can reduce, so that newer binders, that is lime calcine clay cementitious binder, that is geopolymeric binders, where cement free, there is we are utilizing only this one. Carbon negative binder, this is a magnesium oxide, where we are not rather than producing any carbon dioxide, rather than we are absorbing from that. This is a carbon negative binder. And low energy, different type of low energy binders has been developed in due course of time, and people are working on that. Few I have tried to make few binders, that is calcium aluminate cement, that is they have added limestone, crushed limestone, bauxite, and really that work is going on and they have found it's okay. Somewhat they have found that there is a strength loss by conversion of metastable stable hydrate. So, but overall there is no problem into the functionality. Calcium sulfoaluminate cement, this is the limestone, bauxite, and gypsum. This is a little bit expensive in nature. It expand. In addition, some people has reported the durability, but work is going on. Composite cement, I have told that they are about only Portland clinker is up to 30 to 35%. Balance 60 to 70% is GGBF, that is ground granulated blast furnace slag and fly ash. Definitely, its initial strength is lesser, and it's required extended curing durations. And that was another composite limestone cement. Similarly, again, we are utilizing as a filler alkali activated binder, what I have said as geopolymer binder. Definitely, we have worked at CBRI and two component means based, but right now we are working on single component or single part like a cement binders, and we are improving its rheology and setting time issues. Super sulfated cement, carbon negative cement, what I have discussed, that is a magnesium silicate. It's a due course of its uses, and this that has been taking a lot of carbon dioxides and making strength and durability. Still, fewer things are being known. I have said this limestone calcined clay cement. It is. I have told that we have not think beyond our ordinary Portland cement, because we have started working for last 2 centuries. We know its each and every property, and by that we could not thought, but in this we have blended not good quality limestone. This is the second type of limestone waste and calcined clay. Clay is being calcined at a lesser temperature, about 6 to 800 degrees centigrade, and overall CO2 reductions is about 30%. And we can have in India that in abundant quality of low grade clay and this limestone. So we can utilize and produce a good quality this material, and few manufacturers has come up and they are making this type of newer things, and it will be one day you'll find that people start using, because so much pressure on our reductions on our energy demand as well as CO2 emissions. So that another is a belite rich Portland clinkers. So this is being, and it has been invented in China, and rather than several other countries, they have started looking into that. It's mineralogical. If you look into that, it's similar to ordinary Portland cement, but a little bit different, because it has belite content is the more in this cement, and by this our energy demand, clinkering temperature is get reduced from maximum up to 1450 degrees centigrade to only 1300 to 1350 degrees centigrade, and overall energy saving is about more than 10%, and so that overall its properties is good, and a lot of high belite cement is being used all over the China. They have been few manufacturers they are producing and utilizing. If you look into this beta C2S, what belites I have said, they have a high quantity as compared to other C3S or alpha C2S and other things. This specific gravity is about same, little bit higher than this one, and other property will be the same. So another is Belite calcium sulfoaluminate ferrite. It is another type of cement. Here, clinker requirement get reduced up to 30% as required in the OPC, and by this we can reduce both energy as well as the CO2 emissions, because this will be lesser. So I am quickly showing the properties of BOI of the cement, and specific surface is about 443 meters square per kg, density is 2.97, our specific gravity is 2.97, particle size D10 is 2.4, and a different researcher has worked on this, and they have found this one I was telling. This is a magnesium silicate cement, or sometimes people say as carbon. Is not been commercialized much, but yeah, it has a future. You know that it's a due course of time, it's absorb carbon dioxide. You know that if you are people are aware, recently I was looking into the sustainability, you know, with that MIT, they have calculated that a concrete, simple concrete, if you are used into the, it's in lifetime, whatever carbon dioxide of its produces during its construction, so about 50% of that is being absorbed, and being availability of their calcium hydroxides and other things. So about, and it's converted into the carbonate. So means concrete is not as you know that very, it's also absorbs some carbon dioxide from the atmosphere. So that is the important thing. And another is the carbonated calcium silicate type of cement. This is again, it is low lime calcium silicate phase, and gypsum addition is not required during grinding process of this clinker. And overall, if you look into that, that clinkering temperature is around 1200 degrees centigrade, which is 250 degrees centigrade lesser than the ordinary photo. It means overall our you know, have a sustainability aspects to look for other type of cementitious binder into the country, or you know, our approach should be like that. I'm not going with this one, but definitely geopolymer binder is going to have another, you know, breakthrough. Just people are working. We are also working at CBRI and single component, because only you know that it's a handling issue, and if we are able to have a proper single based, we have tried into the laboratory level, but yeah, in a demonstrative level, definitely it's require a lot of time and energy. So if you can able to develop this one in a bag form or a single part form, definitely it will change a lot of thing, and we can achieve a very good binding materials, where about 80% reduction in CO2 emissions. So a lot of its uses has been done, and it's all on two part, but definitely we are working on single part basis. So we are continuously modifying our things. So that part where I have been a newer type of cementitious binder we have discussed, are cementitious or other type of binders which have impact overall reduction into our you know, energy requirement as well as to CO2 emissions. So that was the basic thing. Next, if you look into that, that is a presently is worldwide. If you look that our aggregate part, about 50 million tons of aggregate means required by the world, and we are not getting good quality aggregates. So if you look into the coarse aggregate as well as a fine aggregate, there is a big scarcity of this you know, fine aggregates. So you know, 50 billion tons is a huge quantity. and it is being used into the road sector. If it is asphalt or concrete, it's a building, all infrastructure everywhere as a WMM or we are whatever we say. So that is the biggest issues, and then we have to have look into that how these demands can be met by this one, and not only meeting the demand, also minimizing our disposal issues. So this is Ministry of Urban Housing Affairs estimate that there is about 100 million tons produces nations wise, but it is on very conservative data, because there is nobody gives their data by municipal way. And that if you look into that recycling plant or the worldwide, only because this the data is a little bit older. Right now, bigger plant in India is more than 7. Presently, it is only what whenever I have shown, that is Burari in Delhi, Shastri Park in Delhi, Ahmedabad, Mumbai. Right now, it has come some other cities, Pune, and a smaller plant has come up about 8. But looking into that requirements, every municipal corporation should have, bigger municipal corporations should have a recycling plant. They should recycle all constructions and demolitions waste and convert into the aggregates or different type of building or constructions product. So overall, and we are in India, we are being much more lacking towards that. And I tried, this is the, some photographs taken, and if we can understand the problems, what are the problem is this type of aggregate, we can modify by the processing and removing those unuseful materials and separate it out, and we can use as a similar material. So that, and this is being the requirements, is the need of our, and different type of products people are utilizing right now with these as a fine aggregate as well as a recycled coarse aggregate. So that both are being that this is they have made Delhi integrated waste processing plant. So that has been processed, and not only this, they are also you are making energy from their municipal waste also. So that is also they are again coming as ash, and that ash is being, I have suggested making at sequestration, carbon sequestrations, and make as a aggregate centered into the aggregate. So those, so different type of, if you look into that recycled concrete aggregates, where will only use as a concrete demolished material. If it is a bricks and other things, it is known as a recycled aggregate, recycled fine aggregates, and a lot of products those people are making at the site itself, building blocks, their put that paving blocks, and also people are taking from concrete to make their housing requirement or infrastructural project requirement. They have a small plant of capacity of 35 cubic meter per hour concrete production. So that is the important part. What I have said, that you have to understood what was the problem, why people are not using this recycled concrete aggregate. So this is the problem. This is existing. If you take same analysis of your recycled concrete aggregate. So this is actually aggregate that has been used at that time, from where demolitions has achieved, and this is old cement paste. And if you can look into that, these are making these adhered mortar, adhered cement paste is being honeycombed, or not very much this one. So this cement paste is a weakest zone into that, and if we can improve by this cement or adhered mortar zone, or by removing, by grinding, or by carbonaceous way, so we can achieve a good aggregate with this recycled concrete. So that was our major concern to look into that. So this is this is why these are being, if you look into that, adhered mortar is the loose. Similarly, if you look into the fine aggregates, they all have some elongated part as a recycled fine aggregate. So those things, and you have other than those materials, silica. If you look into that rivers and a high silica content, this is being calcium carbonate content. But here, this in this you have to get some calcium silicate hydrates and other cementitious properties binding things. So not only we have characterized different type of C&D waste, we have to do how we can improve by mechanical way, improve their properties, how we can have by chemical, by different with this interfacial zone, and achieve a good strength. Not only this, we have done with different mixing processes, increasing the mixing time and adding the cement or finer parts into that, and yuking into that. I am not going much into those details, but definitely those things are be there. So that utilizations of those recycled coarse aggregate and fine aggregate is utmost important thing. And that mindset right now, we have revising again IS 383 2016 to make more and more other type of aggregates. So one of it is the steel slag. People get little bit confused with the iron slag. Iron slag is basically that what we know, that is the blast furnace slag, and because based on their furnaces. So this was the iron slag. Blast furnace slag is a very high level of amorphous material, and the majority of those are being used into the productions of cement. And why not that has been used into the cement, that in aggregate? Because if you look into that, those slags has a free line, and then processing of those, removing those free lime, and that can be utilized as a fine aggregate as well. Some months back, GSW has launched in Karnataka and other places of their slag fine aggregate, and I have told that blast furnace slag is a very high level of amorphous content and high level of silica oxide. So it is very good into the addition into the cementitious material, or making slag cement as well as a composite cement. So, but if you look into the steel slag, it is the making of steel. You know that after processing of iron ore, that iron slag is being generated, that is a blast furnace slag. These steel slags are being generated, and in India about 138 million tons per annum, and only 20% is being utilized. And government of India has taken a very strong step, and we are part of that Ministry of Steel, that CBRI, Central Road Research Institute, IARI, and other research organizations, how we can utilize those in a big way. So we are working towards using as a aggregate, as a cementitious binder. IARI working on agricultural, that Central Road Research Institute as a aggregate into bituminous asphaltic, as well as their sub base like wet mix macadam and other thing. So steel slags has a different on their processing, that is the BOF, also known as a ladle, Lansdowne LD slag. This is a BOF means basic oxygen furnace, EAF slag, electric arc furnace slag. This LF, that is the ladle, it is the secondary process. AOD, that is been from this. So if you look into BF, blast furnace slag, is from iron making, and these are the steel making processes. So about 90% or more than 90% of BF slag is being utilized into the cement production. So that was not a big issue into that, but balance here, this is the steel. So we worked on both the area to utilize into the as a coarse aggregate, as a cementitious binder. So and successfully be demonstrated. This is if you can see, this is electric arc furnace slag, and their specific gravity is very high. It varies from 2.8 to 3.2. So it will not be very good into the building sector, but particularly marine structure, and as a road sector, it can be a very good material. We worked on this electric arc furnace slag processes, and that uh, we have utilized into a different making of concrete, rather than we have demonstrated as a tetrapods and road constructions and other activities. So I have told that specific gravity is very high, and water absorption is 1.39, bulk density. And if you look into that impact value, crushing value, and abrasion value, it's very strong, better than the normal aggregate. And it has been mainly made of calcium oxide, and have a high level of Fe2O3. It varies from 18% to 30%, and they process it during their slag, and they take, if it is more than 30% again, and that can be used into that production of steel. So these are the, I'm not going into this. But this is, that they have, if you look into that mineralogical or morphological compositions, they have lernite or wistrite or magnetite, all are cementitious material properties, but it is in form of crystalline. So because crystallinity is a very high, so it can't be utilized as a cementitious binder, but due to very high hardness, it can be used into the coarse aggregate as well as a fine aggregate. We worked on both coarse aggregate and fine aggregate, and we have looked into the different processing and knowing the other material. Free lime we found 0.89, but if you can keep in the open, it will be reduced about 70%. We have done different processing of this aggregate by carbonations, by steam curing, by open means natural weathering, and by the microwave weathering. So that all those things has worked, and everybody is the reductions, but we found that within the 3 months it will reduce. And free lime will be, if you utilizing into the concrete by masking effect, that is not going to have much effect on the concrete properties, means whatever the expensive behavior that has been marked within the cementitious compound. So that was the issues here. We have compared same, we have used making electric arc furnace slag as well as control concrete. Strength was very high into the electric arc furnace, because having a rougher surface and our cement paste, those, and same way as that tensile strength, here that flexural strength and modulus of elasticity, everything was much more beyond that. Only thing is that its density is about 2.8 to 3.2, 2800 to 3200. So it will be very good for making tetrapods, or where weight is being a playing important thing. We have also worked, because this is a part of our this activities, to make to reduce those free lime into this to CO2 mineralizations. And not only we have done in a laboratory farm, we have done on other parts also. I am just giving you a glimpses on that. So how we are on-site CO2 capturing permanent emissions, and these are the different. We are not. I am going. This is a different type of carbonated biomass. I have told that municipal is making a lot of different type of that. Then we try to make it and carbonate with the CO2 mineralization. So nowadays, if you are listening, everybody is saying that how we have to capture the carbon dioxide from cement industry or any type of industry, steel industry, and utilizing those. So we have those things we can do into the laboratory level, and by this, not only steel slag or everything, and adding with the CO2 under pressures, and we can get different type of coarse aggregate and other things. By this we have enhanced our properties, enhanced our money and value to money things. That is the important things. That I'm not taking much on this, only one slide I would like to say, one or two slides. We have looked and worked on different type of alternative fine aggregates at CBRI, and we have developed and published and we methodology for that, looked into the crushed rocks and recycled fine aggregate, coal bottom as steel slag, that is called LD slag fine aggregate. And we have done extensive studies and given that how we can use all those things. And if you look into that coal bottom as, if you can replace your natural fine aggregate by 30%, there is no problem, no loss in any strength and other property. Same thing happened with the recycled fine aggregate. You can go a replacement up to 30% with the nature. So means different how much that has been done. And we have also optimized that, and we have developed minimum paste and maximum density mixed proportioning system, so that we can have a better into that. In this we can minimize our cement consumptions as well. So if you do M30 grade, it's required about cement 380 kg or 375 kg. So if you do with the minimum paste and maximum density, so it has only about 340 to 330 kg. So you have a saving into the cement. So because we have worked on other areas as well, that is stone waste, like quota stone, marble dust, and other lime tailing, that so those area I will quickly go through that. I'm not taking much. So limestone, it's all nearby Rajasthan. Initially marble dust was in abundant, but that this our ceramic industries, tile making industry, they are taking in a huge quantity from Rajasthan to Gujarat. So that has been minimized, and so we worked on that. We carefully created mixed proportioning, and knowing those property, we have developed different technology, and that has been that transferred to nearby industries, and they are making that their small industries, they are making with the lightweight block. And where finer, we are making a aerated autoclaving system and blocks also with these materials. So that has been done. This is the properties has been achieved. So this is, I'm not taking much on that. Different type of tiles has been made, and they are making it has been developed at CBRI. They are making much more better than us. So that is the important thing. So Another, I am been heading to another group that is called polymer plastics and composite group. So we do a lot of work on plastic utilizations or materials. So we have developed and that patented and technology was transferred to one agency. They have producing, that is a wood without tree. So you know that rice husk, and we have taken PP, polypropylene virgin things, and then we have added, extruded those things. These are the rice husks. You know, in India, it is about more than 20 million tons per annum, and a lot of rice has been used as energy productions. They use firing their those things, and that has a very high thermal stability, and average particle size is of that 170 micron, and these are the different types of this. We made a granule, and we make a granule, and making a granule and then making different type of pellets profile and seeds. You can have these is being produced in our laboratory, and then they are making decking material, profile, benchmarking, and other things. All those things has been carried out effectively and efficiently. So, and if anybody is visiting to CBRI, whole technology is available. They can look, and two more industries is interested, but they want other material in place of PP. So we are working, that is a Fentesa and other. So we are working on that. I have told that we have worked on producing those, steel slag to make as a cementitious binder. I have told that cement, and these are the different type of LD slag, EF slag, and those. I'm not taking much, but our main aim is to steel slag washing, then thermal treatment, mechanical size, activations, and then we have converted into the steel slag. So that was the issue, and our one paper has published with that 30% of steel slag has LD slag has activated, and benchmarking has done with the ordinary Portland cement. So clinker factor was reduced about 60%. Our aim is to reduce clinker factor by 50%, means about 45% of steel slag as well as 50%. That has published our paper, so you can see in my name. So those are the few. Yeah. Another aspects, if you look into that, that is lime sludge. These lime sludge is nothing but generated from paper industries and other places, because what they use a lot of this sodium hydroxide for their converting their removing lignin from their things, so that those, and they have to recovery those sodium hydroxides, and from they use lime from the recovery plant. But because you know that in India there's agro based paper industries, and that a lot of silica content is get consumed in this lime. So if they again recover those lime sludge to calcium oxide, so it's a very cumbersome, and lime clean is get energy consumption is increased, but lime is very cheaply available. So what they do, they take out and throw into the lime sludge. We characterize those lime sludge. We have carried out different activated chemically, and added with their agro ash that is being produced from their paper industries, and adding with the 10% to 12.5% cement, we are making a brick blocks and this blocks. And recently we have converted those technology and demonstrated. Recently we have worked with the low cost by treating this lime sludge into making white putty. So that is another area. Another is a bagasse, as I'm not taking because much time, and so that we can have some time for questions hour and discussion. So we have worked on bagasse as also. It is a very good material, and we have found on that. Same thing, I have said it, quota stone, and this is the slurry, and we have is a powder less than 70 micron, and we worked on making aerated autoclave blocks. So those are been, and these are the technologies has been transferred with the 3-4 industries into the different part of the country. So these are the cost. I'm not taking much on that, but quickly, and we have demonstrated, and this Rajasthan State Board has been. I'm going to summarize with this, but these you have to utilize newer type of material, emerging technologies to look forward on sustainable construction. And what I have said, we are continuously on working how that we can modify our code and guidelines and this one. And I will not forget to end my this presentations with this quote of Oliver, that 100 years after we are gone and forgotten, those who never heard of us will be living with the results of our actions. So thank you very much.
Thank you, sir.
Yeah.
So now the session is open to the audience. So if you have any queries, please ask to the our speaker. Or else you can chat in the chat box also. I'll read the questions.
Yeah, please, if you can. Yeah.
Most of them are working in the Congress. If you ask the question, kindly ask the question. Sarah is waiting to reply for you.
Yeah, that few things I would like to tell the audience, and that online audience, that that there is a very new, because I always been taking a part or this in Naurithi, that is being organized by BMTPC, Building Material Promotion Council, New Delhi. So we have worked on newer type of housing system, and if you go on their website, they have uploaded a few their YouTube things you can download and look, and a lot of new materials in India has been introduced. I can recall the secretary, present secretary to Ministry of Housing and Urban, some 2-3 years back, we are in a meeting. He has said very much that if you want to allow that new technology or new materials to enter into your market in name of that study has not been carried out, those studied has not been carried out, so it will never come up into the market. That allow, we should construct few houses, we should utilize those materials, and so that we can know their properties, and whatever the improvement or something is required, we can modify and we can. So I can recall, and really thanks to that Durga Shankar Misra, present secretary, some 3-4 years back, and he has given a lot of opportunities to different institutions, BMTPC rather than Ministry of Housing, to make a lighthouse projects, and by with the newer technology and different building, multi-storied building has been constructed with the complete 3D unit, with that sandwich panel, EPS sandwich panel based system, light gauge steel systems, and BG Cirque 3S systems, means composite concrete building systems. So those are is been need of the hours. If you don't allow, or if you don't work on that, on newer materials, and you are holding in the name of some that in a different codal, Indian standard codal, and the code is right now is a very, BIS is very active to modify their code as early as possible. Whenever new materials are coming, they are interested to incorporate, because this is the time. Otherwise, people just withheld it. Okay, that should not be used on this. So you can look into BMTPC sites, and you can get some new. We used to teach, my lecture notes are also available on that, so you can look into that. So initially, because I was suffering from fever for last 3 days, high viral fever. Still it is, I am speaking under fever of 101 degrees centigrade. So but because it is a commitment, and so I have been in office. So thank you. So you can ask if you have any questions.
So a few questions are asked in the chat box, sir. How
Yeah,
to go for lightweight materials from conventional?
I could not heard you. Your voice is cracking. Hello,
Sir,
hello.
how to go for lightweight materials?
Yeah,
Hello, sir,
yeah, I
lightweight
can get.
materials.
Yeah. There is, that different sintering technologies are available, rather than fly ash and other material has been sintered, and lightweight aggregates has been prepared, and that is been, so sintering processes has been carried out to make lightweight materials, and that is available. Those people is been selling, and different ash based, and different this is few industries, there has already been aggregates rather than coarse aggregate, lightweight coarse aggregate. They have made in a place of Odisha nearby Bhubaneswar and other. So by sintering, you can make a lightweight aggregates. If you're talking about aerated autoclaving, if you have a finer materials, if it has less than your particles is less than 50 or 60 micron, so you can put different type of aerating material, that is alumina based, it is available into that, and you can make aerated blocks, etc., whose densities varies from 600 kg to 1000 kg per meter cube, and utilized into partitions wall or other places. So that is the well established technology. Yeah, next please.
Sir, if a bagasse ash are
Yeah.
using for concrete mix, formation of binder will act same as conventional cement.
You know that if bagasse adopting
Sir,
concrete mix forms, binder will act. This bagasse is nothing. It's a very rich into. It's a pozzolanic material. So that this bagasse is a pozzolanic material. If there is unburned some bagasse is there, it will be there, and the masking effect, it will be in a concrete, but its pozzolana is a very high of bagasse. It's a very high, particularly of rice husk RHA, very high, pozzolanic activities of rice husk. But this bagasse is being there, and it is only as a work as a pozzolanic material, not as a binder. Means it can be supplementary cementitious material in place of our conventional cement. So next he has said, can we prepare bagasse by burning the raw material? Yes, this is been not only you have to burn. These sugar cane industry, they when they make the sugar, they they utilize those bagasse after crushing, so that is available in huge quantity. So you have to take and this one you can use those things. I hope I have cleared to Anusa. Another question is how the efficiency of yeah, you know that Muthu Kun Raman, it is a very effective. Rather than I have published a paper utilizing this ANN on particle packing density. So it has trained well, and results are coming very good. So it is a very effective tool rather than doing every time experimental of particle packing density. So and I have already published a paper on that. You can see few other papers has done on ANN using their geopolymer and other particle packing. You can look into that. Okay, so there is a Divya Sri. What extent of carbon foot is generated from Yeah, it is well established. 8% of total global our CO2 greenhouse gas emissions is by the construction industries. And that a lot of I have told what research steps can we take to reduce. Yeah, I have told that measure carbon dioxide. If you look into the construction industry, that is being major is a cement industry, another is a steel industry. Both are producing very high level of carbon dioxide into the atmosphere. I have told that 1 ton of ordinary Portland cement produces about 0.66 to 0.85 ton of carbon dioxide into that. This is majorly due to calcination of calcium carbonate lime being converting into calcium oxide, and CO2 it get emitted into the atmosphere. So it's been so a lot of initially 95% carbon dioxide is being by this one, but a lot of industry, that cement industry has optimized and they are reducing. So it is been about 66 to 80% of carbon dioxide. So that two things people are working, particularly in the cement industry. One is to reducing this CO2. We are utilizing other pozzolanic materials like fly ash, mainly fly ash, and in OPC you can use up to 10% of fly ash in name of as a admixer and performance enhancer. 5% recommended as a performance enhancer. So any pozzolanic materials have finer than the cement particle. You can use those things. And next one is that they are improving their system so that we can reduce the calcining temperature. But what is happening? Initially, lime was coming a very good quality, but our lime is being getting poorer and poorer. So calcinations again, energy is getting high. So continuously, people are working on this, how we can reduce those footprint, and a lot of research is going on. And I have shown you that in India, first plant that Tata Steel has put some 5-ton capacity at Jamshedpur in steel industries. They are capturing 5 ton per hour carbon dioxide, and they utilizing blowing up of their slag. So they started utilizing. And similarly, cement industries was, that only not you are going to capture the carbon dioxide from the that from fume or something. A lot of other NOx, that is NO, that is nitrogen oxides and SOx, sulfuric oxides and sulfur based oxides. socks and knocks are available, so you have to remove. That should not harm if you are going to utilize somewhere. So those things, and researchers are working. It is a very promising area right now, Divyanshi, and really it will be have a very great effect on carbon capturing and carbon sequestration. So that is, we have, my group is working on this, and this one. I hope I have answered every questions. If any
So
person,
one more question is left, sir. So
yeah.
any code is available for design of geopolymer concrete?
Yeah, code is available. I have sent, that there is not a mixed proportioning for product. One Indian standards code are available. And last time I have sent, right now I will send again to that Prabhu, Dr. Prabhu, and he will distribute all of you. Indian code has come up. Few more codes we are being for mixed. We have not mixed proportioning. We have not met, but definitely code has come up. One code has, and geopolymer products has come up in Indian standard in 2020. It has released in 2021. I will right now, rather than within 2 minutes, I will WhatsApp to Dr. Prabhu, because his uh, is available with me. I will do within 2 minutes time. Yeah, anything more? Any question, please? Yeah, please.
So that's all, sir. That's all, sir. No more questions,
Uh,
sir.
so I am sending that code to him, and but it is available. Plenty of code all available on this on geopolymer guidelines, rather than but it codes, because a mixed proportioning is very difficult, because it's based on individual materials properties. I have told that cement is we are working for last 200 years, and we are well versed with that. And that one that we have established everything. And but if you look into that, I will take 2 minutes to send this to Sona College. I have already forwarded code to Prabhu, Dr. Prabhu, and this is the use of alkali activated concrete for precast product, that is IS 17452. So this is in 2020. I am writing this, and he can forward to all of your persons. 17452. This is 2020. Okay, so yeah, this is, I have also written into the chat box. So, and the code can be received from Dr. Prabhu. Yeah, thank you. I hope it was a very good interactions, and it is a good interactions. I don't know, uh, Mahabir Singh Rawat. Yeah, he's one of my colleague. If he is same person, I don't know. Okay, thank you. So thank you, Dr. Prabhu, and thank you, madam. Thank you all, HOD and principal of Sona College of Technology, Salem. And so I'm thankful to each and everybody. Okay.
Thank you so much, sir. Thank you for accepting our invitation, sir.
Thank you. Thank
We
you.
received your code, sir. We received the answer.
Okay.
Ma'am, HOD,
Thank.
ma'am. So participants, any other queries or you want to talk, means you can please talk.
thanks to all.
Thank you so much, sir.
So
Thank you
thanks
for
to
your
all.
deep input.
Yeah. So really, it's a good for that. Yeah.
Please take care of your health, sir. Even your illness also, you have given acceptance for our invitation and given a nice presentation, deep input on sustainable materials, sir. Thank you so much, sir. Dear participants, feedback link for today's session is posted in the chat box. Kindly fill it. And one more information. So today's afternoon session by Dr. Ajay sir is cancelled and his schedule was postponed to 8th October. 8th October 11:30. So due to some official reason for Dr. Ajay sir, today's afternoon session is